Today, let us understand about a governor. So, first of all, what is a governor? A governor is a device which is used to maintain the mean speed of an engine by regulating the fuel or working fluid, whatever it might be, that supply when the load changes. So, it maintains the mean speed. And why do we need a governor? So there are two cases that we need to know. Case one is whenever the load increases, what happens is the engine speed decreases, and the governor increases the fuel supply in order to compensate this engine speed. So engine speed returns to normal, and for the case two, load whenever it decreases, engine speed increases, and governor reduces fuel supply, and the engine speed returns to normal. So these are the two cases. As load increases, governor increases fuel supply, and as load decreases, governor reduces the fuel supply. Now we need to understand that governor and flywheel are completely two different things. So let's try to differentiate between governor and flywheel. So governor controls the mean speed, and mean speed means whenever the piston moves up and down, the average linear speed of this piston when it moves vertically up and down, that is mean speed of engine. And flywheel, it controls the speed fluctuation. Fluctuation is nothing but any irregularity in the speed. Now coming on to governor, governor acts whenever the load changes. For example, if the load increases or decreases, as we have seen in the two cases above, and flywheel acts during every engine cycle. Now a governor controls the fuel supply or the working fluid supply, and flywheel on the other hand, it stores and releases energy. Now coming on to the types of governors, governors are basically of two types. One is the centrifugal governor and the other is the inertia governor. So centrifugal governors can be further classified into six types: the Watt governor, Porter governor, Proel, Hartnell, Wilson Hartnell, and Pickering governor. So let's understand each of them one by one. So first of all, the Watt governor, it is the simplest form of a governor, and it only uses centrifugal force. It is suitable for low speed engines. These are the three significant points you need to remember for Watt governor. And coming on to the Porter governor, it is similar to Watt governor, and it has a heavy central sleeve. And central sleeve is nothing but a sliding cylindrical component that moves vertically up and down along the central rotating spindle is nothing but a rotating rod or stick. You can think of it as a rotating rod in machines. And coming on to the next point, it is suitable for medium speed engines. The Porter governor is suitable for medium speed engines. Then coming on to the next type of governor, we have the Proel governor, which is more sensitive as compared to the Porter governor, and it is suitable for higher speed engines. So two points you need to remember are: it is more sensitive than the Porter governor, and it is suitable for higher speed engines. And then coming on to the Hartnell governor, it basically uses a spring instead of a heavy central weight. So instead of a heavy central weight, it uses a spring, and the design is very compact, and also it is suitable for high speed engines, just like the Proel governor. And Wilson Hartnell governor is spring controlled governor, and it has better speed regulation, and it is used in high speed engines. Now coming on to the Pickering governor, it uses leaf springs. This is just a basic diagram of a leaf spring, like how a leaf spring tends to look like. So leaf springs are basically something that you see in trucks or vans. It stabilizes the axles in trucks or vans. So yeah, and it is also lightweight, and it is used in small engines. And the next type of governor that we have is inertia governor. And inertia governor works on the rate of change of speed, and it responds comparatively faster than the centrifugal governors, and it is also more complicated and rarely used. Now, coming on to the working principle of a centrifugal governor, we know that in order to explain the working principle, we need to have a basic diagram of a centrifugal governor. So, a centrifugal governor has a spindle in the middle, and the arms support the fly balls, and the arms are linked to the sleeve with links, and there's a sleeve, and then uh, first thing we need to remember is, as the engine speed increases, the centrifugal force increases, and the fly balls move outward and sleeve moves upward. So the fuel supply decreases and the engine speed becomes normal. So how does the fuel supply decrease? So there's this continuation of the diagram where we have a bell crank lever, which is connected to a throttle valve, and there's this working fluid supply. So as the sleeve moves upward, the fuel supply is reduced and the engine speed becomes normal. Now, coming on to the other case, as the engine speed decreases, centrifugal force also decreases, and fuel supply increases and engine speed becomes normal. Now, coming on to the applications, there are several applications of governor: steam engines, power plants, etc. Thank you.